in the Antarctic, the Thwaites Glacier is threatened the most. Now, the Thwaites Glacier is one of the largest in the world.
And so IceFin was developed in part to be able to get us to those places that aren't reachable.
And so what we discovered under this ice is that there's lots of like staircase features. They look kind of like long amphitheaters. You can see these little terraces forming.
In the shadows of secrecy, the National Aeronautics and Space Administration has embarked on daring expeditions hidden from public knowledge. But they're not venturing into the unknown alone. Enter Elon Musk, the enigmatic tech genius and billionaire extraordinaire, partnering with NASA in a mission that promises to shatter our perceptions. Together, this dynamic duo has pooled their resources and unleashed their insatiable curiosity to plumb the mysterious depths of our vast ocean. Beneath the waves, during their audacious joint venture, Elon Musk and NASA stumble upon an unforeseen marvel. Its implications are so far-reaching that concealing it becomes an impossible feat. A revelation of such magnitude demands a bold voice, and Elon Musk steps forward to share his unnerving discovery with the world. But why does he take the lead instead of the renowned space agency that initiated the venture? Join us in today's video as we uncover the truth behind Elon Musk's stunning revelation of NASA's terrifying underwater revelation. Elon Musk, in covert collaboration with NASA, has been orchestrating a series of strategic maneuvers that promise to be the most groundbreaking scientific partnership of our time. However, their joint expedition took an unforeseen turn when recent revelations shed light on the extensive ventures NASA and Musk embarked upon, some of which unfolded in the Arctic. The chain of events commenced with the deployment of an underwater robot by a team of researchers, unveiling a spectacle that defied all expectations. This remotely operated underwater vehicle, known as IceFin, delved into the depths of a seawater-filled crevasse within Antarctica's colossal ice shelf. As the vehicle's cameras relayed their findings, a mesmerizing transformation unfolded before the astonished eyes of the scientific community. The once cloudy and smooth meteoric ice walls morphed into a green and rugged texture, signifying a remarkable shift towards salty marine ice. Simultaneously, NASA, Elon Musk, and New Zealand researchers observed this astounding phenomenon from a vantage point 1,900 feet above, immediately recognizing it as a groundbreaking demonstration of ice pumping, an occurrence never before directly witnessed in an ice shelf crevasse. Justin Lawrence, a visiting scholar at the Cornell Center for Astrophysics and Planetary Science, vividly described the awe-inspiring atmosphere within the room as this unexpected sequence of events unfolded. We beheld the mesmerizing sight of ice melting below us, flowing into the crevasse and then refreezing. And as we ascended further, the inexplicable continued to captivate us, Lawrence shared. The unparalleled insights gleaned from IceFin's unprecedented exploration of the crevasse unveiled over a century's worth of hidden geological processes beneath the ice shelf. This momentous discovery profoundly impacted the entire research team, prompting them to document their findings in a published paper. The comprehensive reports were derived from the CAM Ice Stream Field Campaign, backed by Antarctica New Zealand and other research organisations from New Zealand. Led by Professor Christina Holb from the University of Otago, the team received invaluable support from Elon Musk as well as NASA's astrobiology program. Working in conjunction with Brittany Schmidt, an associate professor leading the Planetary Habitability and Technology Lab at Cornell, they successfully joined forces and deployed the remarkable IceFin. Schmidt's team had dedicated nearly a decade to developing IceFin, and the astonishing results it yielded served as a testament to their unwavering commitment. By complementing the recent investigations of the rapidly changing Thwaites Glacier, also facilitated by an IceFin vehicle, this analysis promises to refine sea level rise models by providing unprecedented high-resolution views of the ocean. The exploration encompasses not only the sea floor, but also the intricate interactions between ice and contrasting glacial systems within the West Antarctic ice sheet. The Thwaites Glacier, vulnerable to warm ocean currents, stands as one of the most precarious ice masses on the continent. Meanwhile, the mostly ice-covered CAM ice stream has remained dormant since the late 1800s. However, if activated, CAM has the potential to contribute significantly to rising sea levels, amplifying the region's overall impact by 12%. Antarctica, a complex and dynamic system, demands our attention on both fronts: the swiftly transforming systems and the more serene ones that hold future risks, remarked Schmidt. By studying both CAM and THWAITES in tandem, we gain invaluable knowledge about this enigmatic realm. NASA and Elon Musk joined forces to provide financial backing for the development of IceFin and the exploration of CAM, expanding the boundaries of oceanic exploration beyond Earth. The discovery of marine ice within the crevice holds significance, as it could serve as a parallel for conditions on Jupiter's icy moon Europa, which is the primary focus of NASA's upcoming Europa Clipper mission set to launch next year. In the future, subsequent lander missions might directly search for microbial life within the ice. Equipped with a comprehensive range of oceanographic tools on a modular frame, IceFin boasts a diameter of less than 10 inches and a length exceeding 12 feet. It was carefully lowered through a borehole created by New Zealand researchers using hot water into the ice shelf, connected by a tether. Over the course of 3 dives, spanning a distance of 3 miles near the grounding zone where CAM transitions to the floating Ross shelf, IceFin diligently mapped 5 crevasses, while simultaneously recording vital water conditions such as pressure, salinity, and temperature. The team also conducted a thorough analysis of various ice attributes, capturing details on water mixing and melt rates. Among the intriguing formations observed were ripples, vertical runnels, golf ball-like dimples, and peculiar features around the top of the crevasses resembling brinicles, consisting of ice globs and finger-like protrusions. The researchers postulate that the ice pumping phenomenon within the crevasse could potentially contribute to the relative stability of the Ross Ice Shelf, which happens to be the world's largest ice shelf by area, approximately the size of France, in comparison to the vulnerable Thwaites Glacier. Peter WASHAM, a polar oceanographer and the second author of the paper, highlighted the protective and self-healing qualities of large ice shelves, stating a lot of the melting that occurred near the grounding line results in the refreezing of water, forming marine ice that adheres to the bottom of the ice. IceFin's mapping efforts on the sea floor reveal parallel sets of ridges believed to be remnants left behind by ice shelf crevasses. This discovery provides a historical record of 150 years of activity since the stagnation of the CAM ice stream. As the grounding line retreated and the ice shell thinned, the crevasses gradually lifted away. Lawrence, the lead author of the paper, emphasized the ability to establish a direct link between the seafloor features and the observations within the ice, enabling a unique opportunity to rewind the process in a sense. The research undertaken received support from various programs, including the Planetary Science and Technology from Analog Research Programs, Project Rise Up, and future investigators in NASA Earth and Space Science and Technology Program, which were backed by NASA and Elon Musk. New Zealand's Antarctic Science Platform and the United States Antarctic Program also played pivotal roles in providing assistance, along with the involvement of the Hot Water Drilling Initiative from Victoria University of Wellington. However, this wasn't the only joint creation of Elon Musk and NASA. Scientists and astronomers have long known that exploring the oceans beneath the icy surfaces of distant moons requires more than just basic tools. With his vision of colonizing Mars, Musk joined forces with NASA once again. Their collaboration led to the development of an underwater rover called Buoy, designed to navigate the challenges of ocean worlds like Enceladus and Europa. The ice shells on these moons serve as windows into the hidden oceans below, where understanding the chemistry of the ice is crucial for uncovering potential life. At Australia's Casey Research Station, Buoy will embark on a month-long expedition, exploring both inland lakes and the ocean to study the interface between water and ice. Unlike traditional submersibles, Buoy overcomes the obstacles posed by ocean currents and power consumption through its unique buoyancy-based design. This 1-meter-long rover crawls along the underside of the ice, propelled by the denser water below, with large wheels on each end facilitating its movement. NASA's robot also possesses the ability to autonomously power on and off while collecting data, with a particular focus on prolonging its operation beneath the ice without recharging. Beyond its mobility, this rover is programmed to carry various instruments, including cameras and probes to measure factors like oxygen levels, water temperature, pressure, and salinity. As data from Buoy's initial missions returns, scientists eagerly anticipate incorporating additional instruments into the tests. However, even with extensive testing, the rover faces a significant challenge in extraterrestrial exploration, identifying potential life forms that may appear dissimilar to those on Earth. Dan Beresford, a mechanical engineer involved in the project, highlighted this in a NASA statement, stating that detecting life forms divergent from what we know on Earth could prove challenging. Elon Musk's team of scientists, intrigued by the statement and the deep-sea expedition, confirmed another discovery previously speculated by NASA. A decade ago, during a NASA-sponsored ocean expedition, scientists stumbled upon thriving populations of phytoplankton beneath the Arctic Ocean's sea ice. Now, in collaboration with Musk, researchers are utilizing underwater instruments and NASA satellite to gain further insights into this peculiar finding. Evidence of significant blooms beneath the sea ice has been uncovered, shedding light on phytoplankton, which are plant-like organisms that absorb sunlight, absorb mineral nutrients, and generate energy through photosynthesis. Phytoplankton can thrive in sunlit areas of the ocean, sometimes becoming visible when conditions are favorable. They play a crucial role as a food source and carbon recycler for the planet. However, it was commonly believed that phytoplankton growth in the Antarctic Ocean was limited by the ice cover, which hindered sunlight penetration. Nevertheless, new evidence reveals cracks, thin spots, and gaps in the compact sea ice that allow sufficient daylight to reach the water below. While the ice cover may appear impenetrable from satellite views, NASA's ICES at 2 laser technology has unveiled fractures and openings within the Antarctic sea ice. Sunlight filtering through these cracks fuels significant under-ice blooms in the Southern Ocean, a phenomenon previously documented in the Arctic, but now confirmed in the Southern Ocean. The expansive, suitable conditions for under-ice blooms in Antarctica surpass those in the Arctic, potentially leading to substantial plankton masses when considering the overall area. This groundbreaking expedition conducted by NASA and Elon Musk has brought forth remarkable findings. However, the discovery of phytoplankton and its implications leaves us with mixed emotions and uncertain expectations. What do you anticipate for the outcomes of these discoveries? Share your thoughts in the comments section below.